For this lesson, we want to do a part 1 of geometric probability. Now our objective then is I can find geometric probability, and what geometric probability is, finding probability using like areas of figures, maybe lengths of things, maybe angles, using those in the context of probability. Now let's talk about probability. Probability is always, when we measure these things, we use the formula of it being success for whatever the constraints are that we're talking about over the total. So if we're talking about finding success, what is it that we want to find the probability of, and what's the total possibilities? If you put success over total, you get your probability. Now if you think about it, if it's always successful, that would be total over total. Well, that's equal to 1. And if it's never successful, that would be 0 over the total, which would be 0. So probability always has to be between the number 1 and 0. Now, we list probability usually in one of two ways. There will be times you'll want to list it as a fraction, and there will be times we want to list it as a decimal. What I'd like to do is I'd like to show you the first problem, then I'll have you try one. So let's look at this figure here. We've got a 12 by 20 rectangle. That's our outside figure. If you would imagine that we would throw something at this board and it would land inside of this green 12 by 20 rectangle. What we want to know is if it lands in there at random, what's the probability it would land inside the circle? So the circle would be our success in this case. So when I do probability, in this case, I'm going to do probability, I'll label that as a P of the circle. The success will be the area of that circle. So let's find area of the circle, which is pi times radius squared, the radius being 3. So we do pi times 3 squared. The total area is the entire green rectangle, so it's going to be 12 times 20. Now when we multiply that out, 3 squared gives us 9, so we have 9 pi over 12 times 20 is 240. That's the exact answer in terms of a fraction, and you should reduce it if you can. In this case, we've got our fraction reduced if we were to reduce it by a 3. But what we're going to do is we're going to list it as a decimal. In that case, we're going to give an approximation. So we're going to do 9 pi divided by 240. And to reduce that, we get it down to 0.1178. Notice 0.1178 is between 1 and 0 as a decimal. Now, what I'd like to do is you have to remember what the formula is for a trapezoid. I'd like you to try what would be the success of it randomly landing inside this blue trapezoid with a height of 2 and a base of 8 and 6. When the entire region is this 12 by 20 rectangle. You try it, pause the video, give it a try, and then we'll come back and we'll do it together. Okay, now that you tried it, let's come back and do it together. So let's do the probability then of this trapezoid. Now to do the trapezoid, what we want to do, if you recall, our formula for this, which is going to be the success on the top, is going to be 1/2 the sum of the bases, 6 plus 8, times the height, which is 2. On the bottom, on the denominator, for the total, we're going to have the whole area being 12 times 20 again. So to multiply that out, 6 plus 8 gives me 14 times 1/2 times 2 still stays 14 when you multiply that out. 12 times 20 still is 240. Again, you could do that in reduced fraction form if you were to reduce it, and that would be exact. Let's go ahead and give an approximate, though, decimal answer. So if we go 14 divided by 20, we get 0.0583 for our answer to that. Notice that decimal again is between 1 and 0. Now, let's do one that's just a little bit different. What I'd like to do is I would like to try finding the probability that if we threw something and it landed in this green rectangle, that it would land outside of both the circle and the trapezoid. So it's in all this area outside and between these figures. Now to do that, if you think about it, what you want to do is say that the total over the total, the highest probability we could get, if you didn't have either of these figures in there and it just landed inside there and say the total success, total over total would be 1. So how we figure out the probability of outside the circle and the trapezoid, to do that, you always take, if it's outside a figure like that, 1 minus what the probability is inside, because that's all the space around it. So you take this area here and subtract off the 0.1178. You subtract off the 0.0583, the two other areas, and that will give you all of this area outside here, and that will be our probability if we put it all over, because we've got that total amount figured out. So 1 minus those gives me approximately, when I do that, 0.8238 for the geometric probability of landing outside those two figures. So geometric probability is finding the success over the total. For today, we wanted to talk about how we do it with area. And what you do is, for the success, is you find the area of the one region that we're aiming for, and you put it over the total amount, find that answer in either fraction or decimal form, and we have geometric probability.